Alright, my apologies, the last video got cut out at the 15 minutes mark. And I'm going to just start over with part E of number 8. So, even though this is given as n should be greater or equal to 4, our answers should be the same. One of the examples I gave in the previous video is when n equals to 3. So, if I do this one over, assuming that our n is 3, just for the simplicity, then if we have this, then the probability of n preceding 1 and 2 will be we would have just 3 cases. So 3 is our n at this moment. So we would have the cases where it would be 1, 2, or 2, 1. So this is 2 possible cases out of 6 total. So this will get us to the answer of 1/3. And feel free to play around with the different number. What if our n is 4 or n is 5? It should still give us the same answer as 1/3. Alright, so let's go ahead and work on the next problem, which is number 12. Alright, so suppose that E and F are the events such that the probability of E is 0.8 and probability of F is 0.6, and we have to show that this is the case. Okay, so I guess in our textbook, according to the principle of inclusion and exclusion, we have the rule such that the probability of, I guess in this case, is E union of F. This is probability of E plus probability of F minus probability of E and F. And I think we've been talking about this. We've definitely seen this during the first 2 chapters when we were talking about the true and false tables. And the proof of this can be probably the most easily explained using the Venn diagram. Okay, so let's plug in what we know or what we're given. So probability of E is 0.8, and probability of F is 0.6. We still have a cup of that, and so this would be 1.4 minus P, E, and F. So by the definition of probability, we know that probability of some event should always be less than or equal to 1. Okay, so let's play around. I'm gonna add P. I'm gonna add this one to both sides, and at the same time subtract 1 both sides. Okay, so if I do this, I have 0.4 is less than or equal to probability of E and F. And there you go. So we have just proved that this is true given our numbers of the probabilities. Alright, so let's take a look at the next problem, which is problem 17. So this problem, we're kind of starting with the assumption that E and F are independent events. So if E and F are independent, then we know that probability of E times P of F, this would equal to P of E and F. Alright, so this at this time is true because that's what's assumed. And knowing this or utilizing this, we have to find out if negation of E and in F if they are also independent or if they're not. Okay, so let's try to find the probability of the negation of E times P of F. Okay, so the negation of E, the probability of not E, is the same thing as 1 minus the P of E times P of F. So this is just by the distribution law. We have P of E minus, sorry, that should be P of F. Minus P of E times P of F. Okay, so we have this, which could be also the same thing as P of E and F. And I'm just use the simple rule of substitution. Okay, so we got to here. I don't think there is anywhere else we can go. So let's just think about this. Okay, so P of F, this is the same thing as, let's see if we can write this differently. So I'm gonna draw a quick Venn diagram. This is E and this is F. So in this case, F consists of this part, which is the probability of E and F. It also consists the remaining part, this one, and that could be written as probability of not E and F. Okay, so it's the intersection of those two parts, and we're going to have to add that to complete the whole part of the F. Okay. So from here, if I divide or if I subtract P of E and F intersection, so if I subtract this from both sides, so I have P of not E intersection of F. This is P of F minus P of E and F. So this is identical to this, which means this equates to P of not E and F. So ultimately, we have probability of not E times probability of F equals to this, which means that these two events are independent. So we were able to prove that these two are independent events. Alright, so the next video is what is the conditional probability that a randomly generated bit string of length 4 contains at least 2 consecutive zeros given that the first bit is a 1. So assume that 0 and 1, the probability of that is the same. Okay, so we are working with just two numbers, either 0 or 1. And it has to be a length of 4, so I'm going to give myself 4 spaces. And it seems like the first spot has to be occupied with 1. The remaining 3 spots, we have a choice. It could be either zeros and ones, but our condition is that it has to have 2 consecutive zeros. So here, our possible cases is that 0, 0, 0. Okay, so that contains at least 2 consecutive zeros. Another case is it could be 1, 0, 0, and last possible case is 0, 0, 1. All right, so we have 3 possible cases, and how many were there total? So we have 3 spots. Each spot, we can have 2 choices, either 1 or 0. Same thing here, same thing here. And these being independent events, we have a total of 8 cases. So there we go. This is our answer to 25. All right, number 26. Let E be the event that a randomly generated bit string of length 3 contains an odd number of ones, and let F be the event that the string starts with 1. Are E and F independent? Alright, so let's actually list out all the possible outcomes of E. So for E, we can have, it contains, so it has a length of 3 and contains the odd number of 1. So let's think about the number having one number of 1, okay? Because 1 is an odd number. So the possibilities are 1, 0, 0, and also 0, 1, 0, and 0, 0, 1. That's all of our choices. The next odd number, bigger than 1, is 3. So the case of having 3 ones is we just have one case, which is 1, 1, 1. Alright, so that's our event E. Let's talk about event F. So F, it is an event that the string starts with 1. Okay, so it has to start with 1, and we can have 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. I think that's all the cases. Alright, so if it's independent, we have to show that probability of E times probability of F, this is going to equal to the probability of E intersection of F. So we have to show if this is satisfied. Alright, so first off, what's the probability of E? We had 4 cases. Okay, so 4 cases, and out of how many total? So we had 3 spots, and each spot we have a choice of 2. So 2, it's either 1 or 0 times another 1 or 0 and 1 or 0. So the total number of cases is 8. So the probability of E is 4 over 8. Same thing, probability of F, we had 1, 2, 3, 4 cases, and the total number of cases we can have is 8. We need to find the probability of E and F, and in this case, we have 2 numbers that repeat. So E intersection of F, we have 2, and this would be 2 out of also 8. Alright, so we need to see if this is true. So 1/8, it's the same thing as 1 over 2 times 1 over 2, and 2 over 8 reduces down to 1/4, which makes sense. So yes, these 2 events are independent.